Good evening, Suryadeep. Suryadeep, shall we begin?
Let's wait for 2 minutes. Start at 9.
Okay. Yeah.
Okay, let's begin. Okay, can we start? Guys, am I audible? And please confirm if I'm audible or not.
Yes. Sorry.
Okay, I think she might have some problem with her mic. No problem. So let us begin today's session. So this will be, I think, session 4 on our fundamentals of RNA-Seq series. And today we will spend most of our time doing some hands-on R coding. Okay, I will take you through the very basics of R in the next 1 hour or so. Okay, I had already shared the script yesterday that I will be using today. I have also shared with you guys tutorials to install R and RStudio. So I hope all of you have done that. If you have not a problem. You can just attend the lecture today, see what I'm doing, and you can use the script. You already have the script at your perusal. Use the script at your own time whenever you have some time and practice it as much as you can. Okay. Otherwise, just like yesterday, if you guys have the script at hand, you may want to open it up and keep it alongside you. Okay. Do a split screen of the Zoom call on the left and the script on the right, opened in RStudio. Okay, I will share my screen and quickly show you how you can actually open the script in RStudio. So once you open RStudio, basically, okay, so there will be this button here called File, right? If you go in here and if you go on to Open File, you should end up with some kind of a dialog box like this. Locate wherever you have kept this script, right? This is the script that we'll be using, and just click on open. Click on the script and then click on open. Okay. So I already have it open here. Okay. So you also can do the same. With that said, let us begin today's session. Okay. So everybody is good on this. People have downloaded and installed R&R Studio. Yes, give me a thumbs up if you have. Okay, one person. What about the others? Okay, complete. Okay, if you have. Okay, very good. Okay then, let us begin. For those of you who have not a problem. As I said, just follow the lecture. You will have access to the recordings. So practice it whenever you can. Okay. Again, this is going to be a hands-on coding kind of a lecture, right? So I will tell you first and foremost that I don't expect you guys to become experts in R coding in just one day. Okay, coding is something that you get used to and that you do and you get good at with practice. Okay, so don't worry if you don't understand how everything is working on day one. Okay, even I did not understand during my first day. It took time and a lot of practice. Okay, this is just to familiarize you guys with R and the environment that you see here, this entire R studio thing, so that in the future sessions when we actually use some R coding, because this is what we'll be using mostly when we perform the differential gene expression analysis. Okay, so in the future sessions when we actually end up using R and R studio, all of this does not seem too alien to you. Okay, that is the purpose of giving you this refresher or a beginner level 1 hour crash course in R code. Okay, so that it does not seem too intimidating to you when I bring in much more complicated R codes. Okay, so I will try to keep it as simple as possible, and we will have discussions. We will stop in the middles, take queries. So no worries on that as well. So let us begin. Okay. Okay. So as a lot of you already might know, R is nothing but another coding language, just like other coding languages like Python, Java, C, C++, etc., 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 etc. R is another coding language. Okay, and R is specifically well known for performing statistical analysis. Okay, statistical and data analysis is what R is the most known for, and a lot of these bioinformatics statistical analysis, like differential gene expression, normalization, etc., etc., a lot of these are very well built in R. Okay, so R has a very large bioinformatics community, and also it has a very good support, right, in terms of bioinformatics. That is why R is one of the most sought after languages in the field of bioinformatics. Every bioinformatician, I believe, should know R, okay, because it is the cornerstone of most bioinformatics, most omics analysis. Okay, so with that said, R that's all there is to R. Okay, you can like understand some of the more like different informations you can get about R from here. Okay, not too important for the sake of the internship. The other thing that I want to showcase to you guys is this, which is R Studio. So R Studio is nothing but this application, which falls under the category of IDs. Okay, ID. So it stands for an interactive development environment. So earlier, when applications like these were not available, people used to use their notepads to write code, or as I showed you guys yesterday, people used to use Nano to write code and whatnot, right? So later, these companies and these organizations, they came up with these applications that actually make coding a lot easier. Okay, so an application that actually makes coding easier for you, that actually helps you to run your code and debug your code easily. That is basically known as an interactive development environment. Okay, and R Studio is one such application. Okay, so here in this window, this is where your script is. This is where you write the R code. Okay, this window is known as the R console. Okay, here you can type in any R command or R code and run it. Okay, that is what this is. You can also access your system's terminal through this. So for Windows guys, it will be your Windows PowerShell. For Linux guys, it will be your terminal, and for Mac guys also, it will be your shell. But by default, this is the R console, as in whatever command you type in R, you can type here and run. Okay, this is basically your environment window, where whenever you run some code, whatever variables or whatever stuff is loaded onto R and is saved, it will show up here for quick inspections. Okay. And this is kind of like a utility window wherein whatever files you load or whatever plots you actually render, all of these will come up here. Okay. And you can actually do a lot of stuff here. So all of these we will come to when we actually encounter such stuff. Okay. Plotting is not something we will take up today because plotting is a bit complicated. Uh, the the whole point of today's lecture is to familiarize you guys with R and the concepts used in coding a little bit. Okay, so that later when we take up more complex pieces of code, when we actually perform the analysis, it does not all seem too intimidating to you. Okay, so with that said, let us start with our very first introductory lecture on R coding. Okay. So before we even go into R coding, let us understand a few basic concepts of coding. The first concept of coding that we have to understand is the concept of a variable. A variable is nothing but a placeholder. Okay. It is kind of like you giving a name to an entity. Okay. Say, for example, this number 10. I want to save this number as an entity. And I gave it the name A. Okay, that is it. So now A basically means the same as 10, and A or 10 can be used interchangeably, right? So you can denote 10 by typing 10, or you can denote 10 by typing A, because that is how you have defined A. Okay. So that is basically what a variable is, right? It is a placeholder. Okay. It holds your values in place. Okay. So a variable can hold anything starting from a number, letters, to a collection of numbers, collection of letters, a whole file, table, etc. Okay. Because at the end of the day, a variable is only a name that holds something for you. Okay. It makes it easier for you to assign stuff. That is what a variable is. And that this is a central concept in coding. Every coding language makes use of placeholders called variables. Okay. So in any language, there is a certain syntax or grammar, basically. So that is basically the rules and the way you write code in that coding language. And in R, this is the syntax that you can see in front of you. I will be talking about the syntax a little bit, but then again, syntax is something that is that differs from language to language. So yes, one part of learning coding is also to learn the syntax, but that is something that comes naturally to you when you actually write your own code and when you keep practicing writing. Okay, so not too much focus on it. Okay, so basically, we use this symbol. We can use this symbol in R to declare variables. Okay, so basically here, if I see this piece of code, right, A, then the left arrow hyphen 10. Right, this is what I have written. So this means that A has been assigned the value 10. Okay, this is what this piece of line means. Okay, and just like any other coding language, R also has a print command wherein you can use this command to basically display anything in the console. Right, display anything for you in the console. That is what the print command does. So what I will do is I will run these two lines. So in RStudio, you have the run button here that you can use to run each and every line here. All you have to do is you have to go to that line, place the cursor on that line and click on the run button. Once you have done that, you will see that it has come up here. And if this finishes without any message that comes up in red that says error, right, that means you have successfully done this line. There is no error with this line. Okay. Similarly, I will bring the cursor here and then again click on run. Now this has printed the value of A, which is 10. Okay. So this is how you're going to be running stuff on RStudio. Whenever you click the run button, the cursor, if you can see here, there is a very feeble, this cursor has already gone to the next line. The next line is some code. Okay. So if I run this, just watch the cursor where it moves. Okay. If I run this, you see the cursor automatically moves to the next line. So RStudio does that for you, right? So that is another feature. Now here you see that in the environment, you can actually see that the A variable has been assigned the value 10. You can also see it here. So this thing will come in very handy for us when we are dealing with large data sets. And I will show it to you when we actually use these large data sets, which would be your counts matrices. Okay. Another way how you can run lines of code in R is by selecting a block of code like this. Okay, I selected these two lines and hitting run on them together. So that will run both the lines or however much you have selected together, and it will run it and output on the console. Okay, so this is how you use RStudio. Okay, if you were to run the entire script at once in one go, all you have to do is do a Control A that would select the entire script, and you can simply click run. That will run the entire script for you in one go. Okay. Otherwise, you can also use this button, source button, wherein it basically runs the entire script for you. Okay. So these are the various ways you can run pieces. You can run pieces of code in RStudio. Okay. So as I said, the first line here, it basically assigned the value 10 to A, right? Here you can see this is the same as this line. Line number 14 is basically the same as line number 17, but it's just that 10 is on the left hand side and the arrow points towards the right. Okay, so in R, you can do it whichever way you want. That is up to you. But this is usually the convention. Okay. Also, another way you can assign a variable is by simply using the equal to sign. Okay. So all of these are the same. I will prove it to you. Okay. So all these three are the same. I personally think lines 20 and 21 is the most straightforward way. Okay. But if you prefer, a lot of people actually prefer this. A lot of people use this. That is also fine. I rarely see people do this, but you can go for any or whichever thing you want. I have no issues with that. That is completely up to you. I personally prefer to use this, and this is what I have used in most of the stuff from here on out. So again, it's a suggestion. I feel this is more straightforward, okay, because this is also the way we do it in all the other, most of the other coding languages. We use equal to sign usually. Okay, so as I said, all these three are basically the same, and you can see why. When I actually run this entire block, you see each and every one of them gives me the same output, which is 10. Okay, so again, this is simply a choice that you can make. Apart from that, God is great, and we can. Okay. So this is about assignment of variables. Okay. Now moving ahead, R can perform a lot of numerical and mathematical like applications. Okay. Now before we move ahead with that, you would have noticed that some lines here are in green, right? Kind of like a greenish tone to it, and they begin with a hash, right? So these lines are known as comments or comment lines. Okay. So comments are an integral part of coding. The use of these comments are basically to explain your code. Okay. Sometimes just lines of code is not enough for people to understand, right? So it is always a good practice as a developer or a coder to actually have meaningful comments in your, as in lines which are in plain English, which actually explain what your code does. Okay, that is what a comment is. And this is what I have been using here for explaining the lecture to you guys. I am using comments. Okay, so a comment line has to begin with a hash. That is all there is to it. Okay, so basically what will happen is these lines are not being read by the R compiler. So when you download and install R, you also download and install something called the R compiler, okay, which basically understands the R coding language and gives you your outputs in the way that it needs to. Okay. So when you put a hash in front of a line, the compiler understands that this is not a line it needs to read. It is a line that is irrelevant to the compiler. So it only reads lines which do not begin with a hash. Okay. I hope that is clear. This is the concept of a comment, and I have added here a lot of comments that actually explain the lecture. So you can also go. So the script itself will act as kind of like your notes or study material for this. Okay. So as I said, R can perform just like any other coding language. It can perform mathematical operations on numbers, right? It can perform all of these mathematical operations. Okay. Just like any other computer language, it uses brackets to basically set operator precedence, as in it follows the BODMAS rule. Okay. And you can also do a lot of these complex mathematical functions, right? You can use all of these. Okay. You would already know a lot of all of these, right? The only two things that you might not know are these two functions, ceiling and floor. So ceiling basically takes the number up to the next possible whole number. Okay. And floor basically brings the number down to the previous possible whole number. Okay. These are two functions which are used very commonly in coding. That is why they are also part of R. Okay. The rest of them are all mathematical stuff that you might already know. If you don't, I have already given the descriptions here. You can check them out in your own time. We will go through a few examples here. Okay. So for the first example, what we have done is I have assigned the value A of 7.5 to A, B is equal to 6. And I will evaluate this exact function, which is A plus B divided by A times B. Okay. And that is assigned the value C. So here you can see that assignment of variables does not only have to be specific. Okay. This variable will hold the value of this expression. So when I change A and B, automatically C will also change. Okay. So it is not specific. Variable assignments are not specific. Variables can hold dynamic values, and that is critical to coding in any language. Okay. And as I said, please remember this: variables are nothing but placeholders. They have nothing to do with what they hold. Okay. C is simply a placeholder for this expression. C does not hold the value that comes from the expression. It holds the expression. Whenever you run this line of code, that is line number 56, in real time at that moment, it evaluates the expression. Okay. And what it stores in memory is this expression and nothing else. Okay. So we will quickly run this block of code and see that yes, R is able to perform math. Okay. Very good. Okay. Another example, very simple example. We have capital A equal to 120.5, small m and small n equal to 2.0 and 3.2. We will evaluate this exact function, which is A times log of m square plus plus n square. Okay. So again, if I select this entire thing and click on run, it would have printed this. Okay. And I hope this is correct mathematically. It should be. Okay, that is the whole point. And as you can see, all the variables that we have defined here are also being shown here for a quick review. Okay. And here you can see in the console, actually, it did not print till all the possible like places after decimal. But in your environment window here, you can actually see that as well. Okay. So you can actually change it to print every possible digit after the decimal as far as it calculates, but it's not really necessary. So let's not go it. Okay, you can anyway see it here, so that is fine. Okay, so this was all about numbers and mathematical functions. Play around with it as you see, as you deem fit. You can also check out this website, 𝐏𝐥𝐞𝐚𝐬𝐞. So this is a website maintained by Professor R. Srivatsan. Okay, he was the professor who taught me R coding. I'm really grateful to him for his knowledge. Okay, he's an excellent guy and an even better professor. So he loves teaching to the point where he has actually uploaded all of his teaching materials online as a free resource for people to learn R and biostats. You can check this website out for more such fun stuff in R and actually learn from this website a lot. Okay. So with that said, mathematics operations are clear for everybody. Yes, give me a thumbs up, guys. Basic mathematical operations, concept of variable, basics of coding, comments. Okay, very good. All good. Let's move ahead and learn a little bit about strings and string operations. So a string is nothing but text. Okay. So just like any other coding language, R is also able to handle strings or text. So basically, any text is basically a string, right? And the way you define a string in R is by using the double quotes. Okay. If you remember in yesterday's lecture, we defined a string by using either a double quote or a single. Okay. So in Bash or in Linux Ubuntu systems, you can do both. In R, you usually use double quotes. Okay. So here you can see that I have defined two strings, str and str1. So it will basically store everything within the double quotes. Okay, even the space is stored. Okay, so the space also counts as a character. That is why it is stored. So if I go ahead and run these two lines, you can see that it stores everything as it is within the double quotes. Okay, we will quickly go ahead and print them. You can see even the space gets printed because the space or any other character or any other punctuation is also treated as a character within a string. Okay. So now a few string operations, of course, we can do. Okay. So the first operation is to get the length of the string or how many letters there are in the string, basically, or how many characters there are in the string, basically. Okay. So that will be given to us by the function nchar. Okay. Now this brings me to another concept in coding known as functions. So a function in coding is nothing but a block of code that you end up using repeatedly. Okay. So for example, some repeated blocks of code. Say for example, this print. Print is a function. Okay. You use the print function repeatedly, right? You might end up uh, printing a lot of times during your code, right? Calculating the number of characters in a string. Okay, that is a repetitive function. You may do this several times in your, right? Then functions like these, square root, round, cos, log, etc., etc. These are all functions. That is, these are all stuff that you might end up doing repeatedly in your piece of code, right? So whenever you might end up doing something repeatedly in your piece of code, what you do is you write that piece of code and you assign it some name. Okay, that is what basically a function is. You write that piece of code, you assign it some name, and whenever you need to run that piece of code on something, say for example, I write a piece of code that can calculate the number of letters in a string. Okay, I have written this. Okay. Now what I do is I give this piece of code the name nchar. Okay. Now whenever I pass a string to the function nchar, okay, so I assign it the name nchar. So all I have to do is call the function by its name, and within brackets, right? Within brackets, I have to pass the name of the string for whom I have to calculate the number of characters. Okay? And what it will do is it will calculate that. Okay, it will calculate that and I can print it and I can see that there are 13 characters. Okay, so this is a function, just like so many other functions. This is a function. Now, nchar is a built-in function. Okay? As in, people who have come up with R already thought of this utility and created a function called nchar. Okay, so they thought of this, that people might have to calculate the lengths of strings repeatedly. So why not just give them a function to do that? That is what people who came up with R already did the hard work for us, created a function and gave us the name of the function, that we can use this function to do this particular task. Okay, so this is what a function is. You might also create your own functions. Okay, it is nothing but a piece of R code that will be assigned a name, and it can take in whatever it needs to take in, right? It can take in these. These are known as arguments to a function. Okay, these are known as arguments to a function. Whatever you pass as an input to a function is known as the function's arguments. Okay, so for example, this nchar function takes in any string as an argument. It can take any string as an argument. Now today I gave it the variable that has stored a string. Okay, I can also give the entire string by itself. Okay, I can actually do that. If I do this, this should also work and give you the same, which is 13. And you can see that this also works. So as long as you are passing a particular string, it is fine. Okay, so the string you can pass as a variable or as the string by itself. Both will work. Okay, because nchar by its definition takes a string as an argument. Okay, is this clear to everybody? Is the concept of a function clear to everybody? Okay, one concept to this. Okay, makes sense. I don't see too many questions. Okay. So now that we know how to get or how to calculate the length of the string, okay, let us see how we can join two or more strings together. Okay, so in order to join two or more strings together, right, we can use something called the paste function. Okay, so the technical term for it is concatenate. Okay, but it is as simple as joining two or three strings together. Okay, so what I will do is I have defined these two strings, str1 and str2. Okay, if I run these, you can see that it has now run, stored in memory, and I can simply use the paste function wherein I pass both the strings as an argument. I will go ahead and do that, and I will print. You can see that it has pasted my two strings into a single string. So the default behavior of paste is such that it pastes all the strings that you pass it as an argument with a space between them. That is what you see. It first put str1, put a space here, and then put xxxxx, right? So this is the default behavior. Okay, if you want to change the default behavior, you can pass another argument to the paste function, which is the sep argument. It stands for separator. That what should be the separator between the strings that you want me to paste. And you can give any string that you want here. Okay, say for example, here I have given 3 dashes. So if I go ahead and run this and then I print, you can see instead of the space here, there are 3 dashes here. Okay, so this is the paste function that is used to actually concatenate or join two or more strings together. I can put anything here. If I want to join the two strings without anything, without a space or without anything, all I have to do is put an empty string here. So an empty string is nothing but two double inverted commas. That's it. That's all there is to it. This is an empty string. If I run this and then if I print, here you can see that both have been concatenated without any space. And notice how the 𝐴𝐷𝐥𝐶, the DNA sequence comes here first, but the X's come here first, right? And the reason for that is, if you see clearly, here I have put str1 as the first string and str2 as the second string, but here I have reversed the order. So that is also something that matters. Whichever string you put first will be put at the first of your concatenated or joined string. So be sure of this as well. Okay. So this is all about paste that can be used to join two or more strings together. Okay. Now let's talk about substrings. Okay. So substring is nothing but a subset of a string. Okay. So a substring can be formed by calling something called the substr or substring function. Okay. And here you have to specify the start and stop character. Okay. So basically what I'm trying to say is, if I have this entire string, mitochondria and Golgi bodies, I will run this, right? So this is a string str which holds these chain of characters basically, right? Now a substring of it, what I am doing is I am passing three arguments to it. The first argument is the string or the parent string of which I want a substring. Okay. The second argument is the start character, that from where do I want my substring to start. And the third argument is the stop character. At where do I want my substring to stop. If I go ahead and run this and then I print it, you will see that it has printed 𝐏𝐥𝐞𝐚. And if you actually see 1, 2, 3, 4, O is the fourth character, 5, 6, 7, 8, N is the eighth character. Okay. So what I did was I took the subset 𝐏𝐥𝐞𝐚 from the entire string mitochondria and Golgi bodies and I simply printed it. Okay. So the substring function allows you to create substrings and you pass three arguments to it: the parent string, the start character, and the stop character. Okay. And unlike a lot of coding languages, in R, you can start counting from 1. A lot of coding languages start their counting from 0. It is known as zero-based indexing, but R uses 1. They have kept it simple for us. Okay. Now, just like we did this, just like we simply printed the substring, you can also replace a portion of the string with some other substring. Okay. Say, for example, I have this string scat, right? Somewhere. Let's see what scat is. Scat is this. Okay. If you remember, scat is this. This is scat. Okay. Now, I want to actually replace a portion of it. Okay. So basically what I did was substring of scat, comma, 4, comma, 8. Okay. So I'll show you actually. If I copy this, paste it here and I run, you can see that this returns me the value 𝐏𝐥𝐸𝐷𝐷, and that is actually correct. 1, 2, 3, 4. This is the fourth character. 5, 6, 7, 8. This is G is the eighth character. So this makes sense that out of scat, I start at 4 and I end at 8. This is my substring. Now what I'm doing is I'm actually replacing it with this. Okay. So this kind of acts like a placeholder for me, right? So this is a placeholder. But wait a second. This placeholder already holds this value. But when I type equal to and I type anything, something which matches the length, right? So this is of length what? 5, right? 4, 5, 6, 7, 8. 5 characters, right? And I have 5 U's here. The length has to match, right? So when I type something with an equal to and then of a length of 5 on the right hand side on the RHS here, what will happen is this placeholder will get overridden, right? This variable or this placeholder actually already holds some value, but I can override it by actually assigning it something else, which is what I will do here. I will assign it 5 U's. And if I go ahead and run this, then I print scat, you can see that it has been replaced by U's. Okay. So this is how you can work with strings. These are some basic string operations. Okay. So this is how you can actually replace certain parts of the string. Okay. By simply assigning its substring value something else. Okay. This makes sense, guys? This last part at least, did it make sense? It's a bit complicated, I think. Yes, give me a thumbs up if it makes sense. Okay. Very good. Okay. Now, in case we want a substring from a given start position to the end of the original string, we can actually do something very clever. Okay. So here you can see we have a string str3, which is a URL www.jobsite.com. Okay. So now say for example, I want to print starting from the fourth character, which is this dot, right, till the end of the string. Okay. So for this, I need to know which one is the last letter of the string, right? So this guy is pretty small, right? It is a pretty small string. Okay. Imagine there was an entire DNA sequence here, which was of 100,000 bases. Okay. I would not even be able to see it on my screen very clearly, right? It would go somewhere like I'd have to scroll down so many pages to actually see it. So it is not possible for me to know the length of the string, right? I don't know the length of the string to actually. So usually, what were we doing in substring? We were giving it the start point and the stop point, the end point, right? Now only if I know how long my string is, then only I can give this number directly. But we can actually do something very clever here. We know that there is a function called nchar that allows us to find the length of the string. So if we were to want a substring that starts at a given position, start I can decide. I want to start from the third position, fourth position. That is something I can decide arbitrarily, right? So I will decide that, and all I have to do is instead of passing the number, I can pass that entire function as an argument to substring. So this opens up a whole new bunch of possibilities, right? Because technically, if I run simply this and I show you guys, I will press enter, you see that what this function does, this function ultimately returns the number 50, right? So when I pass this as an argument to substring, what happens is as soon as substring starts to run, it first encounters this function nchar, and first this function runs. Just like in BODMAS, right? You do whatever is inside the bracket first. So you first run nchar. Nchar actually returns a value of 15, and now this is the same as writing str3 comma 4 comma 15 instead of nchar str3, right? If I go ahead and run this and I print, then you can see it starts from the fourth character, which is the dot, and goes on till the last character, which is M, right? Now I will remove this and I will actually put the number 15. And you can see that it will return the same value, right? So what I did was, I replaced this 15 with the length of the string, right? So yes, you can put functions inside functions, right? And this opens up a whole new bunch of possibilities, right? These are the clever things, these are the clever tricks we do as coders to actually help us out. Okay, so this is something very neat I wanted to show you guys as an example, wherein we put an entire function as an argument to another function. Okay, is this clear how this worked? This particular example? Can you give me a thumbs up? Okay, very good. Okay. Now we can also split a string into separates. Okay, so here I have a string which is file name underscore doc or underscore doc. Okay, so I will load this file name underscore doc. I can see here. Now I want to split this string. So in order to split the string, I can use this function str split or a string split. And what that will do is, here you will give it the argument of the string that you want to split, right? And the separator or the character based on which you want to split. Okay. So here, for example, I want to split it based on the underscore. Okay. So if I run this and I go ahead and print it, you can see that it has created two separate strings. One to the left of this underscore, because that is what I had given it. One to the left of the underscore, one to the right of the underscore. Okay. I could have given here, say for example, the letter T. Then it would have done the same. It would have simply put stuff which is on the left of the D to one side and stuff which is on the right of the D to another side, and created these two strings. Okay. So this is the split function, the string split function in R. Okay. So this is we can also now split strings by special characters such as dot. What all we have to do is we have to place the character after double backslash. Okay. So basically, special characters are characters which hold a special meaning in the coding language. Okay. So in R, the dot or the full stop, right, or the period symbol, that is actually a symbol which holds some meaning in R. So it is usually used to add functions to other commands. Okay. So we'll not go into those details, but a full stop is something that it's kind of like, you can think of it as a reserved character, right? R has reserved the full stop character as its own, and it does some particular function in R. Okay. So now if I want to actually use that to split my string, or if I want to use that, or if I want to use it for my own purpose, right, I have to use something called an escape character. Okay. So an escape character is nothing but a set of characters that tells the R compiler that listen, this dot is not the dot that you have reserved. This dot is something that I want you to look at as just a full stop and not your reserved character. So I put these two backslashes before the dot. Okay. So again, it is nothing but the same function, str split. You can load this string, and what it will do is it will put whatever is to the left of dot here and whatever is to the right of dot here, and that is what we will see, right? Okay. If I would have put just a dot here, I don't think that would have worked. See, it does not work like that. Okay. Because dot means something completely different here in R. Okay. So it is very important for us to put the backslash. Is this clear till here? Because this is all I have for on strings and numbers. Okay. The basics of string manipulation and numbers. Give me a thumbs up if it's clear to you, or if you have any questions still here, please ask. Okay, we have quite a few thumbs up, so we can move on. Very good. Okay, now we will go into one of the most important concepts in R, that is the concept of a vector. Okay, a vector in R is an ordered collection of elements. Okay, it is, so two things here we have to notice. It is a collection of elements and it is ordered. Okay, so it's nothing but basically a bunch of stuff together. Okay, we can have a vector of numbers, strings, or characters. Okay, it is always preferable and convenient for us to create the elements of a vector of the same data type. Okay, so let us understand this by actually looking at these examples. So this is a vector, a vector. Okay, so this vector is basically, you can see that I have basically written a bunch of numbers here separated by commas, right? So it is nothing but, a vec is nothing but a collection of all of these numbers. Okay, the way you define a vector in R is by using this function called C. Okay, so you type C, then inside the brackets you type whatever you need to be inside the vector. Okay, if I go ahead and run this and then I print it, you can see that it has printed all the numbers together And as a matter of fact, I should be able to see here 𝐴𝐵𝐥, right? I should be able to see here 𝐴𝐵𝐥, which is nothing but a numerical vector that goes from 1 to 5. There are 5 elements here. That is what this is telling. Okay, and this is a vector that consists of only numbers. It's a numerical vector. Okay. Similarly, here you can see that I have certain strings separated by commas. Okay. So if I now run this and print, you can see it has printed all the strings, right? And here you can see that this is a character vector of length 1 to 4. So there are 4 letters here. There are 4 strings here. Okay. That is what this means. Now, remember I said it is preferable and convenient if the data type remains the same inside a vector. Okay. It is always preferable, but sometimes it might not be the same. For example, let us take a look at this. This is a vector where there are 1, 2, 3, 4, 5 elements, out of which the third element is actually a string. Although I have written 6.9, since I have written it within double inverted commas, R will think of 6.9 as a string, right? So if I go ahead and actually run this and I print, you can see that it has treated all the others as strings. Okay, and that is the default behavior in R. Okay, in case we create a vector with mixed element types, R treats it as a vector of strings, and even a small number like 32.5 will be converted to a string, which is double quotes then 32.5. This is just an example. Here, as you can see, if the data type is not the same for all the elements in a vector, it will be treated as a string. Each of the elements in the vector will be treated as a string. So remember, a vector is nothing but a ordered collection of elements. Okay, the element could be a number, the element could be a string, the element could be so many more things, right? It is kind of like a list, okay? But it is not exactly a list. There is something completely different in R, which is known as a list, okay? So don't confuse the two. This is known as a vector, okay? And vectors are what we will deal with the most when we are performing analysis, okay? So sometimes it is not possible for us to assign each number or each entry a single variable, right? We have so much data. We generate so much data from these analysis, right? So we have to find a way to um, actually get a collection of these saved together under one name, right? And that is what vectors help us do. If you think about it, this 𝐴𝐵𝐥 is nothing but a variable. And what this variable is storing is this ordered collection of elements. That is all there is to it as a vector. Okay. Now, it is very important to learn a lot of these vector operations, because these are some things we end up using a lot during our analysis. Okay, some basics. Okay, so the individual elements of a vector can be accessed by something called as subscripting. Okay, so subscripting, as I said, it is basically nothing but just a fancy way of saying by using numbering or indexing. Okay, that is all there is to it. Subscripting is nothing but just a fancy buzzword. Okay, so basically what I want to tell you is, if I have this vector, okay, of elements that goes from 10 till 130, right? I will go ahead and run this. Now I have X, which is a numerical vector. It has 13 characters from 10 to 130 in increments of 10. Okay. Now this is basically the subscripting. So what I'm doing is I am taking X, but I am only taking the third element from X. And how I do it is by defining it within the square brackets. Okay. So if I run this, it will go ahead and print it. So you can see that the third element here is 30, and that is what has gotten printed. Okay. So this is known as subscripting or indexing or numbering, however you want to call it. Okay. And we usually read this as X of 3. basically. So that would basically be that you are taking the third element from X. Okay. Similarly, as you can see, since X of 3 has returned a number, right? Similarly, X of anything within 1 to 13 will also return a number. And as you know, you can do mathematical operations on numbers in R. So you can do mathematical operations using vectored elements. Okay, so if I assign this variable, if I assign this variable this operation, x of 3 versus x of 6 plus x of 6, x of 3 is 30, x of 6 is 60. So it should ideally calculate 90, which is what it has done. And if I print, I will get 90. Okay, again, simple enough, right? Now, in order to access specific elements of a vector, we have to give the element indices, right? Indices is nothing but the plural of index. Basically, again, in simpler words, we have to give it the number of that element, right? Or the index of that element, basically. Okay. So if we basically want to create a subvector, again, a subvector is nothing but a subset of the parent vector. The parent vector is this X. If I want to create a subset of this vector that contains some of these numbers, but not all of them, all I have to do is define that, give it the name, some name. I have given it the name C, and equal to, then again, inside a vector definition, I give the indices, right? Remember, vector definition is using this C and then round brackets, right? C and then round brackets. So here, all I'm doing is, if I want the first, third, and sixth elements, if I want 10, 30, and 60 in Z, all I have to do is I will have to tell that, okay, Z is equal to X, then within third brackets, the indexes of the elements I want, but as a vector definition. Okay, so here I will now print Z, and you can see that Z contains only 10, 30, and 60. Okay, it is also possible for us to access the consecutive elements of a vector. Okay, this process is known as slicing. Okay, here, just like the string, we have to specify the start point and the end point. Okay, how we do it again, if you remember, just like here, it has to be within a vector, what can I say, within a vector definition, right? And we basically do it using this colon, okay, using the colon character. So basically, this is equivalent of writing C and then within brackets 4, 5, 6, 7, 8, 9. It is the same as writing that, and I will prove it to you. If I copy simply this and I it here, hopefully it works. See, this is 4, 5, 6, 7, 8, 9. That is what it will return, right? So this we read it as x of 4 to 9. Okay, we read it as x of 4 to 9. So this will basically start with the fourth element and then get till the ninth element and assign it to C. Now you can see it has assigned from 40 till 9. And if I go ahead and print C, it would have printed all of that. So this is all about some math using vectors, slicing in vectors, right? Accessing elements in vectors. Okay, everything clear till here, people? Give me a thumbs up, please. Okay. Is print C equal to C? I did not really get your question. What exactly? Acha, you mean is print Z? Okay, okay, I get your question. So this is another one of the beautiful applications of R Studio, or basically the R console. In the console, if you simply type Z and press enter, it will automatically print. Yes. The same can also be achieved if you actually type print and then within print, if you type Z, that will also give you the same. And that is something that is a beautiful addition of the R console, basically. Okay, but in the script, you should always write the print statement because it might not always run using the console. Okay, when you actually run using the source button, it does not run inside the console. So simply typing Z won't work. So you should, whenever you are printing, you should always use the print statement. Okay, I hope that clears your doubt. Oh. Okay, so let us move ahead. Okay, so once a vector has been defined, mathematical operations like addition, subtraction, multiplication, and division performed on its name are in turn applied to all the elements individually. And that results in a completely new vector. Okay. Say, for example, I have this vector BSTR. So now this vector contains these numbers from 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, if I were to add 100 to all of these elements, right, all I have to do is type BSTR plus 100. That will add 1, 2, 3, 4, 5, 6, 7, 8, 9, all of these to 100, right? I will actually show it to you once simply in the console. If we do that and okay, BSTR was defined. So sorry, we have to run this. Then only we can run this. Yes, you see that it has added all of this. And all we are doing with this add is basically assigning this vector to the name or the variable add. That is all we are doing. So once we do this, we will get this vector, you can see. And again, we are simply printing it. Okay. So this is again something pretty cool here on vectors, right? So again, if I have a variable called mult, which is multiplying 100 to each of these elements, I can simply do it by giving the name of the vector, then the multiplication symbol, and then 100. All I have to do is this, and you can see that I have another vector here by the name of mult, which has these numbers multiplied by 100. Okay. So again, pretty cool stuff here, right? Okay, so moving on, the algebraic operations between one or more vectors are applied to their individual elements, and a resulting vector is created. That is what we saw. Thus, if we add two vectors of the same length, then their corresponding elements are added to give a new vector. So as we saw that you can do mathematical operations globally on a vector, you can also do mathematical operations between two vectors, okay, as long as the two vectors are of the same length. Okay. So I have these two vectors, for example, I will run them. Now they have been initialized, they are defined. You can see that both are of length 6. So if I want to add element wise, so 10 will be added to 1.5, 20 will be added to 2.5, 30 will be added to 3.5, and so on and so forth. If I want to add it element wise, all I have to do is use the plus symbol, vec1 plus vec. If I go ahead and add this, you can see that I have another 6 length vector where the first elements were added, second elements were added, third elements were added, and so on and so forth. Okay. So again, this is also pretty cool stuff. If you want to do some element-wise operations on a vector, you can do it like this. I showed you addition. You can also do subtraction, multiplication, division, whatever you want. Okay. Now you can also start with an empty vector, or you can start with any vector basically and add elements to a vector. Okay. I will show you this by first initializing an empty vector. So the way you initialize an empty vector is by using the initialization function, but just not putting inside any, right? So 𝐏𝐥 is currently an empty vector. You can see that here it shows up as null. Now what I am doing is I am actually adding stuff to it. So in order to add stuff to it, I type in C, and then within the brackets, I type the vector to which I want to add the stuff. So I want to add these two strings to 𝐴𝐵. So that goes first, and then whatever elements I want to add to it goes next after it, separated by commas. So if I go ahead and do that, now you can see that 𝐴𝐵 has these two elements. Okay. So now 𝐴𝐵 already has these two elements. I want to add more. All I have to do is again the same. C followed by 𝐴𝐵, right? And then followed by with a comma, followed by whatever I want to add. If I go ahead and run this, now you can see that 𝐴𝐵, instead of having 2 characters, it has 4 characters. It has 4 strings basically. So you can add stuff to a vector as well. That is, you can keep adding elements to it, and it will always add it after the last element that is already present in the. Okay. Okay, so just like this, right? So if you think about it, it's nothing but adding elements, right? So if I have three separate vectors, v1, v2, v3, no matter the length, don't worry about the length. Here, coincidentally, they are the same. Okay, no, they are not the same. This is of length 3, this is of length 4, and this is of length 3. Good. So the length does not need to be the same. So if I go ahead and run this, I can actually combine all of them into the same vector by using, again, C, and then by giving it as a comma separated value. Okay. So all I have to do is type in C and within the brackets v1, v2, v3, and it will create one large vector called convec, which has all the numbers. Okay, and the order is what is very important to note here. Since I put v1 first, I got these three. I put v2 second, then I got these four, and then I got these three. That is how it works. So we can combine vectors as well. Okay. We can also generate number sequences. Again, these are some things that come in very handy when we are performing some dummy experiments or when we are doing some simulations, generating number sequences. Okay, so that can be achieved using this function called the seq function. It's a very useful function. Okay, so all I have to do is use the seq function and give the starting number and the ending number. Okay, and it will generate a sequence starting with 1 and ending at 50. Okay, so here it is an integer sequence. That is why you see int in here. Go ahead and print it. You can see that it has generated a sequence at increments of 1. Okay, you can also set the increment here. So what I did here was I passed the start number, the end number, and the increment or the step value, right? So this will generate a sequence starting from 1 to 50 at increments of 5. If I go ahead and run this, then you can see that every number is the previous number plus 5. Okay, and since 46 plus 5 is 51 and 51 is beyond 50, it did not generate 50. Similarly, I can also go the other way around. I can start at 50 and go till 1 with decrements of 5, and here all I have to mention is -5. Okay, very intuitive, right? So again, this basically the same 50, 45, and so on and so on. Okay, so just like we calculated or we identified the length of a string or the number of characters present in a string, we can also calculate or identify the length of a vector. That is the number of elements present inside a vector, right? So we already have a vector called convec. If we quickly calculate the length, we can use this function called the length function, right? And pass the vector inside it as an argument, and it will give us the value. But okay, this convec vector, as you can see here somewhere, yes, it is of length 10. Okay, so these are again some vector operations. Everything clear till here? I think, can we add elements of matrix using vectors? By matrix you mean matrix addition, like in linear algebra, right? Is that what you mean, Shubhajit? What exactly do you mean by matrix? Do you mean the matrices we use in linear algebra? Is that what you mean? Okay. Okay. I'm audible, right, guys?
Yes.
Okay. 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 Shubhajit, if you can hear me, let's take this up after the class then. We need some discussion like this. Let's take it up after the class. Okay. Okay. So moving ahead, we can also sort vectors, right? So again, the vector is nothing but a combination of elements. So most of the time, the vectors will end up containing numbers. Okay. Yes, sometimes they will contain strings, sometimes they will contain a mixture of stuff, but a lot of the times they will contain numbers. So that is why sorting kind of becomes an essential functionality that we need. So sorting again is allowed. It is something that is possible. So let us define this vector x. Now, if I have to sort it, I simply use the function sort and pass the vector to it, and it will sort it in ascending order, right? So the ascending order is the default setting, right? You can change it to descending by passing another argument, which the name of the argument is decreasing, and you have to set it to true. Okay. So when you set the decreasing argument to true, it will sort it in descending order. Yeah, that is what we see here. Okay. We can also get the maximum and the minimum entry of the vector from these functions. This is the max function and the min function. If I go ahead and run this, you can see that the maximum was 123 in the vector and the minimum was 2 in the vector. Okay. A particular element or a set of elements can be removed from a vector by specifying the element index with a negative sign inside square bracket. So again, let us see an example. We have a vector x here. Right? I will first define this, and then we are creating another vector yr. Okay. So this vector yr will basically have whatever x has without the second number. So without 10. Okay. So x of -2 basically has removed the second element of x, which is 10. So if I go ahead and run this and I print it, you can see that 10 now has been written. Okay. Now again, if I want to remove consecutive elements, if I want to remove consecutive elements, that is to say, for example, I want to remove the elements starting from the second till the fifth, right? So all I have to do is just like slicing, if you remember, we gave them as 2, then colon 5. So I want to keep or I want to take out 2 to 5. Here, if I want to remove 2 to 5, I have to give -2 to -5. That is all there is to it. I hope all of this is pretty intuitive, right? That is, I mean, that was the hope of the developers who came up with R. Okay, so YA will basically remove the second element till the fifth element. So 2, 3, 4, 5. These 4 elements will be removed, and we will be left with only 5, 30, 35, and 40. Okay, from this. Specific elements can be removed by specifying the corresponding indices as a vector inside the square bracket. So just like actually use these, if you would not have given these minus signs, what would have happened is basically it would have given the entire thing, but these. So for example, if I define this vector now, what will happen is if I did not put the minus sign here, it would have what? It would have taken the second element, fourth element, seventh element, and created this new vector y. But instead, what will it do if I put a minus? It will remove these. It will remove these entries. So if I remove this, if I now run that, I will see that y does not have the second element, which is 10, the fourth element, which is 20, or the seventh element, which is 35. So I don't have them in y. That is what this is. Okay. So these are some basic vector operations. These are a lot of these operations will be some things that we use from our day-to-day in our day-to-day work, and these are all some things that will come in handy. Okay. Any questions still here? Shubhajit, I will come to your question after the class. Okay. Others, any questions? Okay. If there aren't any questions, we can go on to the last part of our lecture today, which is data frames. Okay. So this is the most important and key thing about R that I want you guys to understand. This, I mean, this is something that you cannot mess up. Data frames is something I need you to understand because we will be dealing with data frames a lot. Okay. So to explain very simply, a data frame is just like a table where each column is allowed to be of a different data type, like strings, integers, floating point numbers. Floating point numbers, again, all that means is that they are decimals. Okay. A data frame is technically made up of individual vectors of the same length placed as columns. If you think about it, each column in a data frame is nothing but a ordered collection of elements, right? So if I have a table, right? If I have a table and I have this column, I have this column, there are so many columns, right? Each column is of the same length, right? People can agree to this. Each column is of the same length. So each column in its own is nothing but a consecutive list of elements, right? It is an ordered collection of elements. So each column in R is basically a vector. And when you stack these vectors together in the form of a table, you end up with something called a data frame. Okay, let us understand this. Let us first define the vector data 1. Data 1 is a vector which is iron, sulfur, calcium, magnesium, copper. Okay, we've done this. Data 2 is a vector of numbers. Data 3 is also a vector of numbers. Now, FRM1 or frame1 can be defined using the function data.frame. You see here, just a quick flashback for you guys, how dot is used as something in R. Like, so this is what I meant by reserved character. Every coding language has certain reserved characters. Okay. So now if I use the function data.frame and if I pass the vectors data1, data2, and data3 to it, I will run this and it will create this data frame called frame1. I can go ahead and print it, and you can see that it has been printed in kind of like a tabular structure. And the names of the columns are the names of your vectors, data1, data2, and data3. So this is where this window becomes very useful. Sometimes for your own sake, you can also visualize it from here. So if I click on frame1 here, I actually have it in a tabular form. I can perform a lot of things here. I can perform sorting, right? Here, based on ascending, descending, or whatever I want, etc. Right? I can perform filtering based on something here or whatever. So this becomes very handy when we are actually dealing with real life data. Okay. So I will show it to you guys when we actually perform the analysis. So again, these are data frames. Okay. So this is how a data frame is. And if you think about it, I will again open and show. If you think about it, each column is nothing but a ordered collection of elements, right? This column is a vector of strings, is a vector of characters. This column is a vector of numbers. This column is a vector of numbers, right? Or to be more precise, this column is a vector of floating point numbers. This column is a vector of integers, right? So this is basically a data frame, which is a collection of vectors stacked together. Okay. So there are two very important functions of a data frame, right? That is, you can use to actually identify the row names and the column names of the data. So if I want to know the names of the row, right? So right now the row name, I don't have any row names here. I only have 1, 2, 3, 4, 5. So those are my row names, right? When we actually use the R code, when we actually use the R code to process our data and stuff, we will end up using the gene names as our row names. Okay, so that is something that is very beautiful, and we will see when we see those pieces of code, we will see how these functions come in handy. So if I simply print row names now, it will print just the numbers, and as you can see, they are all is as strings. So row names are always strings. Okay, your call names as well are always strings, and it will be right now the names of the vector. Okay, I can change the call names obviously, because if you think about it, call names of FRM1, that is a placeholder that already has this data, and we know we can override that by using the equal to sign and assigning it some new value. That is what I'm going to do. I am going to override call names of the name 1, which already has some data, and I'm going to override it using this vector of the same length, right? 3, right? And now if I print frame 1, it will have the column names as this, and I can see the same here as well, right? So this is about column names. I can also name the rows, right? Similarly, just like all names, the row names of frame 1, I replace it with some vector of the same length. I go ahead and run this, and you can see it has been replaced, and I can see the same here as well. Okay, so this is again very cool, very pretty. Okay, now just like vectors, we can also access specific elements in data frames. Okay, so the syntax for it is the name of the data frame, and then within third bracket the row index and the column index. Okay, so basically if I use frame 1 in third bracket 1, 3, that means I want the first row, third column. So first row, third column, that would be 1122. If I go ahead and run this, you can see that 1122 got. Okay, if I want the first row but all the columns, all I have to do is keep the column placeholder empty here. Okay, if I go ahead and run this, see, I am getting only the first column, but all the the first row, but all the columns. Okay, if I want all the rows but any specific column, I have to keep the row placeholder empty. Okay, so this will now basically print all the rows but only the second column. So the second column, you can see it is a proportion column, 12.5, 12.6, etc., etc. That is what is getting printed, right? If I want to print from a particular row to another row, but all the columns, right, I use the colon sign, right? So basically, this tells R that okay, now you get me from the first row to the third row for all the columns, and if I print that, so the first row to the third row, but all the columns. Okay, and similarly, again, this is all the rows, but from the second column to the third column. So all the rows, but only the second and third columns. Okay, so these are some very useful accession like methods to access. You can also access each column by its column name. Okay, so if I want to print only the element column, I can use FRM1 followed by $element. So dollar is kind of like the placeholder, after which you put the name of the column. So if I go ahead and print this, it will print the element column. Similarly, I can print proportion and product ID. Okay. Now remember, each column is nothing but a vector. And just like vectors, we can do math operations on each column, right? For example, if I want to multiply the proportion column by 1000, like each element in the proportion column has to be multiplied by 1000, all I have to do is basically denote the proportion column using this notation FRM1 $proportion times 100. Now FRM1 proportion we already saw, it is a vector, right? So I can perform mathematical operations on it element wise, and that is what we have done. Now if I print FRM1, you can see that each element has been multiplied by 1000. Okay. Now we can also add a new column. The way we do it is using the name of the data frame followed by $, followed by the name of the new column. Okay. Now this becomes your variable or placeholder, right? Now this will be equal to some vector, right? Because each column is a vector, if you remember. If I go ahead and run this, you can actually see it here that I have a new column called sim. Okay. So now I can also remove column using the column name. All I have to do is the name of the data frame, $, then the name of the column I want to remove, and I will set it to null. Because if you guys remember, an empty vector is assigned the null value. An empty vector is nothing but a vector that does not have anything. So it will automatically remove that column. So if I go ahead and run this, if I print, you can see the product ID column is gone from here, and so is it gone from here. Okay. Okay. I can also remove the columns using this notation. If you remember, with third bracket, the first that is to the left of comma, you give row index, to the right of comma, you give column index, right? And if you use minus, it removes in R, right? So if I want to remove the third column, that is a symbol column, I can also put this notation that FRM1 is equal to FRM1 third bracket, all rows, that is keep all rows, comma, -3, that is remove the third column. If I go ahead and do this, you can see that the symbol has also now gone. Okay. So these are some of the basic operations of data frames. Okay. Has everybody gotten to understand this? Everything is clear till here? Give me a thumbs up if it is. Okay. A couple of you. Okay. Yes. Okay. We have a few thumbs ups. We can move on. Now, these are some useful operations for data frames and vectors alike, right? So these are some set operations, as you all know, union and intersection. If you have two vectors, x and y, you can use the union function to actually perform the union, right? If I go ahead and print it, you will see that it has performed a union operation on these two vectors. Similarly, I can also perform an intersection operation using the intersect function. All I have to do is pass the two vectors as I. Same for union. So if I go ahead and run this, you can see the intersection is dn. Okay. Now again, we can sum all of the elements inside a vector, right? If I want a sum of all the elements inside the vector, I will simply go ahead and run this, and then sum of x. Sum is again a function. I put the x vector as an argument, and it will sum the elements in the vector, and that will basically be equal to 29. I can also have the cumulative sum of all the elements, right? The function for that is CUMSUM. I have here the cumulative sum, right? So that is basically every next element is like the sum of the previous kind of, right? That is what cumulative sum is. Similarly, cumulative product is also something that is there called CUMPROD, right? On this, and we can see that is what it has done. You can find the unique elements inside a vector, right? If I have this vector x, I can use the unique function to actually find the unique elements inside the vector. So if there are repetitions and I don't want the repetitions, I will keep only the unique ones. I have it. Okay. Now, another way to do this is by using the duplicated function. So again, if I have this vector x and I use the function duplicated of x on it, what it will basically do is it will return a Boolean vector. So a Boolean vector is a vector of true and false. Okay. So basically internally, it runs the logic that wherever it is a unique, wherever it is duplicated, it will return true. Wherever it's a duplicate element, it will return true. Wherever it's not a duplicate element, it will return false. Okay. So if I want the duplicate elements inside a vector, I will use duplicated of x as my indexing of x, right? So within the third brackets, I will place duplicated of x. So basically what it will do is it will return a vector of trues and false, right? And wherever it is true, it will retain those. Basically, that is how it works as an indexing method. It will retain those where it is true. So for the third and the 4, 5, 6, 7th element, it will retain. Okay. So if I go ahead and run this, you can see it is the third element, right? And the 7th element. These are duplicates, right? So the first A was not a duplicate because at that time this was a unique element. But when A appeared again as the third element, it is a duplicate because the first element was also A. That is how this works. Okay. And if I want to extract all the non-duplicated elements or the unique elements, I have to use the exclamation sign before duplicated. Okay. And this is read as not duplicated. Okay. So this is read as x of duplicated x, and this is read as x of not duplicated x. In most programming languages, exclamation followed by some expression is usually used to mean not that expression. Okay. So it kind of works like that. I will now get all the unique elements here. Okay. Now we can also subset data frames. Okay, so how do we do that? I'll quickly show you guys. So this is a vector of genes. I will go ahead and run this. Then I will create a vector of gender, and I will create these 7 data vectors. So these 7 columns. Okay. Now I will create a data frame. So I will create the data frame dat frame, and it will have all of these vectors basically, right? So I have this data frame dat frame. Okay. Now I will now add the column names. Okay, and I will now create a subset of the data using the subset function. Again, this subset function is something that we will be using a lot. Okay, so the subset function basically helps us to subset data, that is basically retain data that matches a particular condition. Okay, say for example, in the dat frame data frame, right, I want to keep all the entries, or I want to keep all the samples for which the value of experiment 20, experiment 2 is greater than 20, and experiment 52 is greater than 15. Okay, so it would be difficult for us to do it manually and figure out the indexes and then retain those. So we can use a subset function to actually do it based on the condition itself. So if I go ahead and run this, now subframe 1 is another data frame, which is a subset of data frame of dat frame, which has all the entries with experiment 2 greater than experiment 2 greater than, how much was it, 20, and experiment 52 greater than 50. So it will have experiment 2 greater than 20 or experiment 52 greater than 50. This is the OR operator, a single vertical line. Okay, you will see this. This is just below your backspace key, right? This is the OR operator. So it will retain all those entries where experiment 2 is greater than 20 or experiment 52 is greater than 50. And that is what you see here, subframe 1 में. Experiment 2, everything is greater than 20 except for this. But for this, experiment 52 will be greater than 15. Yes, it is 15.6. Okay. So similarly, there is subframe 2 where I am doing it based on the string. So that frame has the gender column, which is a string of M and F, denoting male and female. So now if I want only the data of the females, I can do it based on data frame $gender equal to F. Now that will basically have subframe 2, which will have only the female gender data, right? So similarly, there are several such operations that you can do here. I have given some examples here. Okay, you guys can go through them, right? There are 2 more things that are sometimes important, which is joining data frames. Okay. Again, this is something which is a bit more complicated. So we can cross this bridge when we come to it. That is, whenever we encounter this, I will explain how it basically works. It is not necessary for you to know on the first day. Whatever you have done, I feel we have done quite a lot today, and for a lot of you for whom it is the first time using R, it might be a bit overwhelming, but that is fine. You have this script and you have good comments here which actually explain what is happening. So please make use of the script, run the script on your own line by line so that you understand what each line is doing, and that will actually help you out. Okay. So again, this is not something that you need to learn right now. Some more techniques. This is again something we will come across again when we are actually processing the data. So we will do these whenever we are actually dealing with real data. Okay, that is the best hands-on experience that you can get. Okay, with that said, we are done with our very basics of R. Can we return back to original data set? So the original data set, Shubhajit, if you see, that is already being preserved. Why? Why is that? Because we created this dat frame that is already there. When we are performing the subset function, we are assigning it to some variable, some other variable that is not that frame. So that frame still has the original data. We are not touching it. We are creating subset of that frame and we are calling them subframes, right? We are creating subsets and we are assigning them some other variable name. So yes, you can return, in the sense the original data is kept as untouched. You don't need to edit it. All of these that you see here, subset and all, you can do it in place as well. All you have to do is you can rename this as dat frame. So if I would have written dat frame here, and if I run this now, it will be done in place. As in, inside this dat frame only it will change, and I will have no way to return back to dat frame again until and unless I reload it from the very beginning. Okay, but that is not a very good idea because you might need to return back to the original data. So that is why we use other variable names here. Okay. I hope that answers your question, Shubhajit. Okay, anybody else? Any more questions? If not, we can wrap up for the day.
Thank you, Mr. Suryadev. Dear participants, hope today's session is clear. Please give thumbs up. If you don't have any questions, I'm requesting you all to give a thumbs up and clear. Yes, thank you. I guess, Suryadev, there is no questions.
Thanks a lot.
Let's wind up for today. And do we have any prerequisite for tomorrow's session?
Yes, yes, Shubhajit, I will get to your question. Yes,
And
you
give
will
me a
have to
second
install.
before proceeding with the Subhajit query. Those who are leaving the session, please to fill out the feedback form. This form is not only a feedback form, it also acts as an attendance form. So please do fill it out. Give your genuine concerns and also any suggestions if you have for how we can proceed the session. Please include that as well while filling it out. Yeah, thank you all. Yes, Suryati, please continue.
Yes, so in terms of prerequisites, yes, we will have some installations. I will share the installation guide so that people can do it before tomorrow's lecture. And it's okay, tomorrow's lecture will be a bit chill. I can help you out, but I would prefer you guys use the Telegram channel to sort out any doubts with regards to the installation. You have the entire morning. I will share it within the evening, the installation instructions. Okay, so yeah, that's about it. And okay, with that said, you have Conda hands-on. Yes, anyway, when we'll be using the tools, we'll be using Conda. So after you're done with the installations, we will use Conda. So that is also something that we'll do. Okay, people who have not joined the Telegram channel, please check your mail. I think you should have the link there, right, for me?
Yes, link is already there in me. Anyhow, I will be sharing it now also.
Okay, so to come to your question, Shubhajit, if you could please unmute and ask, that would be better.
Yes, company feedback form is mandatory to fill. I have been mentioning it from day one. If you missed it, no problem, but kindly fill it out from today.
Shubhajit, able to unmute and speak?
Mr. Subhajit, can you please unmute?
Okay, no problem then. If Acha,
Okay,
yes,
okay, I think
yes,
he's going
yes.
to.
Yeah, tell me,
Yes.
Shubhajit. Stop sharing my
So
screen.
my question was like, if we have two matrices, numerical, can we add those
Shubhajit, your voice
groups
is
together?
cracking. Your voice is cracking.
Uh, yeah, I am telling that write those things in my chat.
You're not cracking. Absolutely. Do one thing. You just type it in the chat over there. Your voice is cracking. Okay, so in terms of practice, as I said, it's the more you write, the better you can get at any coding language. So you can check out that website, CountBio. Okay, so that will be a very good starting point for you because it has coding examples as well as the theoretical examples of the same for you to actually understand our coding. Check out that website if you can. Otherwise, the only other way you can actually improve in coding is just by writing your code. So, I mean, just take up a problem, like take up a situation, and okay, I want to load this data frame, I want to perform this subsetting, etc., analysis or whatever. Just set yourself those goals and try to write the code on your own and challenge yourself. Okay? Apart from that, YouTube is always there. Then to learn any language. There are several good tutors on R coding on YouTube as well. But use that website first. That is a very good place to start learning R coding. That is how I started. So before I got to this, I was not a bioinformatician. I was also a wet lab biologist. Okay, I was a microbiologist. So I got into coding. I got into data science much later during my masters. So again, that helped me a lot. So it might be of help to you. If required, if there are a lot of you who want that, if there is a mass request, I can draft in some worksheets maybe for you guys to actually practice some more of art. Okay, coming to Shubhajit, can we add numerical values of two matrices using vector? So, so you mean element-wise addition, right? What exactly do you mean by a matrix here?
Yes, that like you have now numericals value when you have written in that one single row. Okay, when if we have that number, these numbers not in a single row, but a couple of rows, like 3 or 4 rows, in two,
Matrix multiplication you are saying.
yeah,
So
multiplication.
normal
Yes,
linear algebra में जैसे होता है matrix multiplication, is that
yeah,
what you're saying?
yes.
Okay, you don't have to do it using vectors. So R has a data type called matrix itself, which can be used for linear algebraic operations, matrix multiplications, matrix addition, subtraction, and on. So R has a mat. It has a data type called mat, a matrix. That stands for matrix basically, where you can do these operations. You don't have to do it using vectors. You can, and actually that mat operation or that mat data type, that function is defined using vectors because vector is inbuilt. Mat is something that was built on top of vectors. So yes, you can using vectors. That will be cumbersome for because the developers have already created a data type called mat. Does that answer your query?
Yes. Thank you.
So, and a lot of these operations we will do when we actually perform the analysis. Okay, we will deal with matrices and data frames. If you think about it, a data frame is a lot like a matrix, right? It's just that a matrix contains only numbers. That is the difference between them. So yes, we will deal with all of these when we actually get the data. So before that, I just wanted to give you guys a heads up as to how all of this works. That's all there is. Okay. Okay. With that said, I